So this straight line is for here. If it's 0, it's -3. This point is -3. So it's this one and not this one. And the greater than 2. Greater than 2, like 3, you plug it in and you got 0 here. So it's 3 plug in is 0. Greater than 2, like 4 plug in, -1 here. So it's if less than 2, if greater than 2, you use this line. You will use this line. So if you use 2, plug it in here, and you will get 1. Get 1. Get 1. -2 plus 3 is 1 here. So the graph is like this. So when x approach to 2 from left-hand side, the function value is approach to 1. When x approach to 2 from right-hand side, function value, y value is always, this x is 2, y is 1. This is x, this is y. So y approach to 1. When x approach to 2, this x approach to y value approach to 1. And then this graph is continuous over here. F of 2. This is f, x is 2, y is 1. F of 2 equal 1. So limit approach to x approach to 2 from left-hand side. The y is approach to 1. And the x approach to 2 from right-hand side. From right-hand side plus the y value is approach to 1. And 1 is equal to f of 2. F of 2 equal 1. So then this function is continuous over here. Over here. At that point, you can see here continuous. The next question is given the function f of x equal, when x is between 1 and -2, from -2 to 1, is function is x squared minus 1. If from 1 to 2, the function is x cubed. Then ask you, limit x approach to 1 plus from right-hand side. From right-hand side, approach to 1 right plus from right-hand side means x greater than 1 and approach to 1. So x greater than 1, use greater than 1, use this. X greater than 1, use this. Use x cubed, plug it in. 1 plug it in. So 1 cubed, it's 1. And the other one, x approach to 1, negative from left-hand side, which is x less than 1. X less than 1, use this. X less than 1, so use this one. Use x squared minus 1, plug it in. X, use 1, plug it in. 1 squared minus 1 is 0. And since when x approach to 1 from left, from right, they are not equal. Since limit x approach to 1 from right-hand side is equal 1. And from left-hand side, approach to 1 from left-hand side is approach to 0, since they are not equal. So then we say the limit when approach to 1 does not exist. Does not exist because they are not equal. And then ask you, since it doesn't exist, so ask you, limit doesn't exist. So that means the limit x approach to 1 f of x is not equal f of 1. What is the f of 1? From here, when x equal 1, you will plug it in here and figure out is 0. Because here is equal 1, so use this one. 1 squared minus 1 is 0. F of 1 is 0. But limit when x approach to 1 f of x doesn't exist. So this limit x approach to 1, f of x is not equal f of 1. So f is not continuous at x equal 1. If you want continuous, has to be equal. 1 plug in, f of 1 equal. Equal will be continuous. If not equal, then it's not continuous. You also can use the graph to check, to help you to check and draw the graph. So this one, the two functions, one is f of x equal to x squared minus 1 if a negative 2, and another one is x cubed if x between 1 and 2. So I shouldn't have this equal sign. No equal sign. So here, this less than, because equal signs go here and less than here. Only here have equal sign. So this one, you can use you can plug in this 0, this 1, this 2, and negative 1, negative 2. And between negative 2 to 1, and from 1 to 2, from negative 2 to 1, use this graph, x squared. So if you use 0 plug in, will be negative 1. If you use 1 plug in, will be 0. If you use negative 1 plug in, also 0. And use negative 2 plug in, will be 3. 1, 2, 3. It's here. So the graph is this is a parabola up to here, between negative 2 to 1. And from 1 to 2, if you use 1 plug in, will be here. It's not including equal 1, you plug in is 1, but not there's no equal sign here, so it's an open circle. And then use 2 plug in, will be 8. 1, 2, 3, 8 is about here. So the graph is this way. Actually, the whole graph is this way. Whole graph is cube. Whole graph is this way. But since we only define from 1 to 2, so it's going this way. So you can see from x approach to 1 from left-hand side, then y value is approach to 0. 0. And x approach to 1 from right-hand side, the y value is approach to 1. And there is a jump, a gap, a jump. Here open, a gap, a jump. There's a jump. So they are not continuous. So then limit at 1. So since they are not equal, so therefore when x approach to 1, the y approach to what? Does not exist. Does not exist. And then we say, and since limit doesn't exist, so it's not continuous. Not continuous. You can see the graph is not continuous. Now another example, question 5. The question 5a, this is a application problem. Algebra of the function from section 2.2. Algebra of the functions. A. Suppose Puretron, a manufacturer of water filters, has a monthly fixed cost $16,000. Costs, fixed costs like rental, the factory rental fee, or monthly cost, mortgage, $16,000, and a variable cost. Variable cost is X denotes the number of filters manufactured per month, which is filters manufactured, product X filters each month, and the variable cost each month product X filters, the cost is so much. So write down the function, cost function C of X. That gives the total monthly cost incurred by the manufacturer of X filters. So it's a fixed cost per month, fixed cost $16,000. Add the variable cost because this is depend on X. Depend on X how many filters X. So as we call is changed variable cost. The two costs add together is the total cost, monthly cost, and that's the answer. Then ask you B, refer to A. Suppose the total revenue in dollars realized by Purotron from the sales of X water filters per month is given by the total revenue. This is a total revenue function, which is depend on how many filters sell how many filters. If you sell X filters, the revenue, which is the money you earned income is so much, and then that's the revenue function. So A, find the total profit function. That is the function that describes the total profit Purotron realized in manufacturing and selling manufacturing X water filters per month and selling X water filters per month. So the profit, total profit P of X is equal revenue minus the cost R of X minus C of X. R of X is the money you sold and the money you come in, and minus the cost is your expense. So is this function R of X. And the first function is R of X. This function, this one, put it in here for R of X. Minus the cost function, this cost function, minus. Then you distribute it in, become plus. Negative 0.0008x squared. Add, because negative become plus 0.0004x squared. The two are like term. You add together because negative become plus. You add together. And this negative, this is plus. So get negative 0.004x squared. Then 26x minus, here is minus 18x. 26x minus 18x and get ax. And then here minus plus, so it's a minus. This is you need to put the parenthesis. Then remove the parenthesis, sign change. This change to plus. This plus change to minus. This plus to change to minus. So here is a minus. Here change to minus 18x. 26x minus 18x get ax. This minus change to plus. So negative, add. So this negative, add this, and you still negative. So this is the profit function. Then B, what is the profit? When the level of production is 14,000 filters per month. So 14,000 filters plug into the profit function into X. So profit P of 14,000, X is 14,000 plug in, equal negative 0.0004. X use 14,000 plug in. Put the parenthesis squared, 14,000 squared plus A times X use 14,000 minus 16,000. Then you can use calculator. Figure out is dollar the profit is per month is $17,600. So for this question, you got a cost function and got revenue function, and the revenue function minus cost function. Here you need to put the parentheses. Remove the parentheses, change the sign, then you combine like term. You got profit function. Then another question 6. An environmental impact study conducted for the city of Oxnard indicates that under existing environmental protection laws, the level of carbon monoxide, CO, present in the air due to pollution from automobile exhaust will be 0.01 x to the power 2 over 3, 2/3, 0.01 times x to the power 2/3 parts per million when the number of motor vehicle is x thousand, in thousand, x is in thousand. A separate study conducted by a state government agency estimates that T years from now, the number of motor vehicle in Oxnard will be so many thousand. Depend on T years, which year from now. T years from now, there are so many thousand, 0.4 t squared plus 2t plus 62,000 vehicles. From now, T years has so many motor, so many cars. So A, find an expression for the concentration of CO in the air due to automobile exhaust T years from now. So here, this function C of x is the carbon monoxide, CO, is in terms of x, is in terms of how many vehicles, x is x thousand vehicles. The function is in terms of x is 0.01 x to the power 2/3 parts per million. When have motor vehicles are x thousand. And the question A asks you express this. This is a concentration. C of x is a concentration. Existing environment protection, the level of CO, which is a concentration, is this one. And this one is in terms of x. The question asks you, write this function in terms of t years, due to the exact t years from now. So write this in terms of t. So what is the x? X is the number of vehicles. Number of vehicles in terms of t years is this function. So x in terms of t, x of t is equal to 0.4 t squared plus 2t plus 62,000. Now here x also in thousands, x thousand. So now the question asks you to get the concentration C of in terms of t, in terms of years. So the C of t equals C of x. X use this in terms of t, plug in. X of t is this one. So you got C of this. and this one put into x. So this one put into x, get 0.01. This is x. X equals 0.4t squared plus 2t plus 62. Plug in x. So then you got to the power 2/3. So that's in terms of t, become in terms of t. So this one is c of t. C of t is this answer. X replaced by this in terms of t. Then B, what will be the level of concentration 4 years from now? So that means T equal 4. So T use 4, plug in. So T use 4, plug in T, and got 0.01. And 0.4 times T use 4, plug in 4 squared, plus 2 times 4, T use 4, plug in, plus 62. Then to the power 2/3. So then you figure out 4 squared is 16 times 0.4 is 6.4. 2 times 4 is 8 plus 62. And then this add together will be 76.4 to the power 2/3. Then this part, use calculator. Use calculator, you hit the key. You see clear. You will do is here. Is this one? You do 0.01. Then this, you can put the parenthesis 76.4. Put the parenthesis to the power. Use this one. Then 2/3. Put the parenthesis 2. You didn't see my. I'll do again. I'll do again here. You didn't see my what I press, so I do again. It's 0.01, and the parenthesis 76.4 parenthesis to the power. This exponent to the power, and then put the parenthesis 2/3. 2 divided by 3 parenthesis, hit enter. So we'll get is 0.18005, and round it to 2 decimal digits. Normally 2 decimal digits is 0.18. 0.18, and the answer in units here is a parts per million. So answer is 0.18 parts per million. So this is what we call composite function, composition of the function. C of x, use this, plug it in, and then C is this. So this x use this function, plug it in. This is composition of the functions. Do composition of the functions. Next question is from section 2.3, functions and the mathematical models. Question 7. The idea of a large, stable, middle class, defined as those with annual household incomes in 2010 between 39,000 and 118,000 for a family of 3, is central to America's sense of itself. The following table gives the percentage of middle-income adults in the U.S. from 1971 through 2011. So from year 1971, add 10 years, one decade. One decade is 10 years. 81, add 10, 91, add 10, 2001, add 10, 2011. So percentage decline. Middle class percentage decline. 60% are middle income adults on 1971, and then 58% are middle income adults. Decline. So a mathematical model giving this percentage of middle class adults in the U.S. for this period is this model. So you can plug in t equals 0, plug in, you got 60%. This t equals 0 is 60. Then t equals 1, you got 60 minus 2.46, and you will get it is very close to 58. It's 57.54. Is close 58, and you use 2. T equal 2. T equal 2 is 1991. You plug in, times by 2, add 60 is very close to 55. T equals 3 is 2001. So it's negative 2.46 times 3, add 60, and you get a number is close to 53. And you got t equal 4, you plug it in, add 60, and you will get number is very close to 50. So this is represented those approximately. This is the model, linear model, mathematical model given this percentage of middle class adults in U.S. for this period is this model, and the t equals 0 corresponding 71. T equals 0 corresponding to 1971. T is measured in decades. One decade, it's 10 years. So A, what is the rate of the change of percentage of middle income adults in the U.S. over the period from 1971 through 2011? What's the rate of the change, which is the slope? This is the y equal mx plus b form. Slope-intercept form. Slope, it's negative 2.46. This is the slope. The slope is the rate of change. So answer is negative 2.46%. This is a percentage. So add percent per decade. Means a decline of, because negative, so it's decline, decrease. Decline of 2.46% per decade. The middle class decreased by 2.46%. So that's A part. Then B part. Ask you. Assuming that the trend continues, what will the percentage of middle income adults in the U.S. be in 2021? So first of all, you have to figure out 2021 t corresponding t equal what? So it's t equals 0, 0, 1, 2, 3, 4. So next t equal 5 is add 10 is 2, 0, 2, 1. And ask you this. So t equal 5. 0, 1, 2, 3, 4, 5. So it's 2021 corresponding t should be 5. So use 5, plug it into this function f of 5, plug it in t. F of t use 5, plug it in. Get negative 2.46 times 5, add 60. So t use 5, plug it in. 2.46 times 5 plus 60. And then figure out is 47.7. So the answer is 47.7% of middle income adults in 2021. The next question is demand. We talk about the next question is called demand curve and the supply curve. Demand function and the supply functions. A demand curve is expresses the relationship. What is the demand curve? Demand curve expresses the relationship between the unit price and the quantity demanded. Unit price and the quantity demanded. This is a demand, like this one. P is the unit price. P is the price. D means demand of X. X is the quantity. How many units demanded? So this we call demand curve. Demand function is represented for the relationship between price and how many units quantity demand, X, P and X. And in general, the quantity demanded of a commodity decreases as the unit price increases. So when unit price increased, the quantity of the demand decreased, and vice versa. A demand function defined by P equal F of X, where P measures the unit price and X measures the number of units of the commodity in question, is generally characterized as a decreasing function of X. When X increased, the function decreased, the price decreased. When more demand, X increased, the price decreased. When X decreased, the price increased. It's a decreasing function. In general, an increase in the commodity's unit price induces the producer to increase the supply of the commodity. A decrease in the unit price generally leads to a drop in the supply. So a supply curve expresses the relationship between the unit price and the quantity supplied. The supply function defined by P equal F of X is generally characterized as an increasing function of X, which is when X increased, the price increased. The supply X increased, then price increased. That is P of X increased as X increased. So if you have a curve like started at here, this is a price, this is X. When X increased, the price decreased. That is a demand function. And then started here, then when the X increased, the price also increased. That's the supply functions. The two have an intersection points. So this is P equals supply of X. This is P equals demand of X. Demand functions decrease functions, supply functions increase functions, and the two intersect at one point. So that's we call. So the market here say. So market equilibrium corresponds to the point x0, p0, p0, at which is this point, x0, x0, and this side is p, price, p0. This is equilibrium point. A market equilibrium corresponds to the point at which the demand curve and the supply curve intersect at one point. X0 represents the equilibrium supply, and P0 represents the equilibrium price. This should be called equilibrium quantity, not supply. Should be equilibrium quantity. Equilibrium quantity. And then P0 represents equilibrium price. So question 8, example. And the demand function for a certain brand of Bluetooth wireless headsets is given by this function. P is the price in terms of X, how many Bluetooth wireless headsets. How many headsets? X is the number of headsets. And P, and this. And the corresponding supply function P equals S of X equal this function. This increasing function. Here's positive, here positive, increasing function. Here's negative, negative, so it's decreasing function. This started at 80. Here you can see this, you draw the graph, start at 80 and then go decrease, decrease, because minus, minus. So go when X go larger and the larger, the price go 80 minus those, go decreased. And then this increase function is started at 20 when X is 0. Started at 20. And then you add, because positive, so you add. So this is increase function, add. So this is started at high. Price, $80, demand, and go decrease. When the demand increased, the price go down. Supply is and started at $20, and then when supply go increased, the price quantity increased, more units, then the price go higher and higher, and finally get this equilibrium points, intersection points. So then here, P is expressed in dollars. X is measured in units of 1,000. X is in thousand. And find the equilibrium quantity, which is X, and the price, which is P. So equilibrium, which is the two are equal, intersection point at this point, price equal, price P equal. So P equal, that means D of X and S of X equal. So you let D of X equal S of X equal. So D of X is negative 0.024 x squared minus 0.4 x plus 80 equal S of X equal 0.04 x squared plus 0.8 x plus 20. Let the two equal. And go simplify it and solve for the X. So how to solve this? You can move this term to the right side, change the sign, become the two, add together, get 0.064 x squared. Move this term to the right side, the two terms combined, add together, change the sign, become plus. Add together, get 1.2x. Move the term to the right side, become minus 20 minus 80. So it's minus 60 and equal this side is 0. Then you do times by 1,000. Move decimal point to the right 3 position, get 64. Move decimal point to the right 3 position, get 1200 x. Move this to the right 3 position, get 60000. 60000. And times each term times by 1000. So 0 times by 1000 get 0. And reduce, because the common factor here you can reduce by 16. 64 divided by 16 is 4x squared. 1200 divided by 16 is 75x. 60,000 divided by 16 is 3750 equals 0. Then this one you cannot factor. If you can factor, you factor it. If you cannot factor, use quadratic formula. Quadratic formula. Quadratic formula is formula. Quadratic formula is quadratic equation ax squared plus bx plus c equals 0. Quadratic formula is x equals 2a negative b plus minus square root of b squared minus 4ac. That's quadratic formula. Plug it into quadratic formula. A is 4, b is 75, c is negative, including negative sign, negative 3750. X equal to a is 4, negative b is 75, plus minus square root. B squared, 75 squared, minus 4, a is 4, c is negative 3750. Plug it into the formula. And you can use calculator to figure out. And to figure out, it's you got simplify it, and you will get this. After simplify, get this is equal to 2.6. Use calculator, take square root. And we pick up because here is negative 75 minus this is negative, but x is in thousand. It's how many units? So it should be positive 1. So we pick up positive plus. We don't use minus. Minus is going to be negative because impossible negative of units. Quantity should be positive. So you use plus. And use calculate. Figure out is 22. 22.64. And since x is in thousand, so this times by 1000 is move decimal point to the right. 1000 have 3 zeros, so you move decimal point to the right 3 positions. Get 22646.7. Rounded is 22647 in thousand. And this x 22.646, this number, plug into the either demand or supply function. I put it in supply function. X is this. Plug it into the function and get 0.04 times x is this square plus 0.8 times x is this. Plug in plus 20. And use calculator, you will figure out the price is 39.023. So rounded 2 decimal digits. So 39.02. So then you write answer. Equilibrium quantity is this number times to 1000. So move decimal point because x in thousand. So times 1000. 1000 have 3 zeros. So decimal point move to the right 3 positions. Got quantity is 22646.7. 7 is greater than 5. So round up. So it's 22647. So it's 22,647 units. equilibrium price is this in dollar 39.02